In the present class, we are going to solve some of the MCQs on aldehydes, ketones, which are previously asked in the JEE, NEET or CET examinations. Okay, let's start one by one. Okay, the first question is, which of the following compounds will show positive silver mirror test? The question is, which of the following compounds will show positive silver mirror test? We know about the silver mirror test. Which will undergo the silver mirror test? Only the aldehydes. It may be the aliphatic or aromatic aldehydes will give positive result. Okay, here we need to identify the aldehyde. Okay, what is the first one? The first option in the question number 1 is, okay, CH3, CHOH 3 times, CHOH 3 times and CHO, okay, and CHO. It is nothing but C double bond H. Okay, this is an aldehyde. This is an aldehyde. Therefore, it undergo silver mirror test. Okay, come to the option 2. It is CH3, C double bond O, CHOH, CH3. Here, when you look at this structure with respect to the functional group carbon and carbon, this is alpha. So, alpha hydroxy ketone it is. Alpha hydroxy ketone also undergo silver mirror test. Also undergo silver mirror test. Okay. Then come to the option 3. That is HCOOH, that is formic acid. In the previous class, I have told you that the formic acid having CHO part, that is aldehydic part, it also undergo the silver mirror test. Okay, come to the option 4. All of these. All of these. So now, what is the correct option? The question is, which of the following compounds are undergoing silver mirror test? Now, all of these is the correct answer. All of this is the correct answer. It is an aldehyde, undergo silver mirror test. It is alpha hydroxy ketone. This one, this unit is very important. It also undergo the silver mirror test, and here this is formic acid is also having aldehydic part. Therefore, it also undergo silver mirror test. Therefore, our option is all of these. Okay. Next, come to the question number 2. Which of the following is hypnotic? Okay. Hypnotic means what? It brings about the sleeping or hypnotizes us. Means mabbu barutte ante heltivalla. Okay. Feeling unconsciousness and no activity. Okay. Isn't it? So it brings about inactive mode of a human being. That chemical substance is called as hypnotic compound. Okay. Yes. The option 1 is, for question number 2, option 1 is acetaldehyde. We know that acetaldehyde is used as it relieves from nose blockade. When we have a cold, you know, that time when you inhale the inhaler, okay, that brings about relieving the nose blockade. Okay, now it cannot act as a hypnotic compound. Okay, what is the second compound? Metaldehyde. It is not a hypnotic compound. Okay, come to the option 3, formaldehyde. Option 3 is formaldehyde. It is a hypnotic compound. It is a hypnotic compound. Okay, this is a straight question. Formaldehyde acts as a hypnotic compound. Okay, it hypnotizes us when you take this. Okay. Now come to the question number 3. We have a reaction, that is question number 3 is CH3CHO. CH3CHO when treated with the HCHO. Okay. In the presence of dilute NaOH followed by heat. Okay. See, look at this equation. We have a alpha hydrogen containing aldehyde, and this is no alpha hydrogen. Now, in the presence of dilute alkali, it is absorbed in aldol condensation. It is absorbed in an aldol condensation. Okay. Now, these two compounds in the presence of dilute NaOH undergoing particularly cross-aldol condensation. Now, this is having alpha hydrogen. No, it donates the alpha hydrogen to this carbonyl oxygen. Okay, if you take this as Hc double bond OH, this hydrogen will be captured by that oxygen. That C will be attacked to this. Okay, now what we will get? We will get COH. Okay, then this side we have H, this side we have H. No, we shall call this as CH2. Okay, then this CH2 will be joined with this carbon CH2 CHO, and after heating, this is the compound upon adding dilute NaOH. Now, upon heating, what happens? Condensation will occur. No, that is the removal of a water molecule. OH minus will come from this, H plus ion will come from this. Here, there will be formation of the double bond. So, in the first step, you will get this one, and in the second step, after heating, H2O will come out. It will be CH2 double bond CH, CHO. Okay, and this is having continuation. This is compound A. Come to the next one. When this aldehyde is treated with HCN, what happens? And followed by the hydrolysis. Let us take that. It is treated with the HCN. To have a clarity, I am going to write this as this. Okay. Here, double bond we have, carbonyl we have. Carbonyl group is more polar and active. That is why this HCN attacks on that. Here we have a negative bond, cyanide ion, and the positive bond, H plus ion. Here, H plus ion joins with this oxygen. Okay, cyanide joins with this. So it is nothing but nucleophilic addition reaction. Okay, here we will get CH2 double bond CH, COH, H, cyanide. Okay, and on hydrolysis of this acidic hydrolysis, we will get. See here, when you do acidic hydrolysis, it won't act on the double bond. It will disturb this cyanide. Cyanide is nothing but C triple bond N. Here, any cyanide on hydrolysis will give the carboxylic acid as a product. So now we will have the corresponding carboxylic acid, that is CH2 double bond CH, COH, H, COOH. Okay, this is the compound. Now look into the given options. The option 1 is CH2 double bond CH, CHOH, COOH is the compound. So option 1 is correct. In this way you have to solve. First you need to identify what kind of a reaction is going to take place between these two reactants. See, the reagent, when they use the reagent dilute NaOH, you should immediately connect with the aldol condensation. Okay, so it is aldol, and after condensation you are going to get this. Okay, then when it is treated with HCN attacks on the carbonyl group, not on the double bond, because before it is going to attack, okay, before the HCN attacks this double bond, it is more active one, polar one, that is why it directly attacks on this. Okay, and unsaturation will be present as it is. and hydrolysis of the cyanide is going to give you the carboxylic acid. It is very important in our further discussions also. Okay. Now come to the question number 4. Formalin is an aqueous solution of formaldehyde. What is formalin? The question number 4 is on formalin. Formalin is 40%. Formalin is 40% aqueous solution of formaldehyde. Aqueous solution of formaldehyde. So therefore, option 3 is correct. Option 3 is correct. Okay. Now come to the question number 5. An organic compound A has the molecular formula C3H6O. What is the question number 5? It is an organic compound A has the molecular formula C3H6O. Okay. It undergoes iodoform test. So recall the iodoform test. The methyl ketones will undergo iodoform test. Now it is a methyl ketone. For example, it should be there. CH3 C double bond. This is called as a methyl ketone. Okay, now what is left? 2 carbon atoms are over. 1 more carbon will be there. 3 hydrogens are over. 3 more hydrogens will be there. This is the compound A. Okay. Now, an organic compound A has the molecular formula C3H6O. It undergo iodoform test. Now, what is the compound? Acetone. Okay. When saturated with HCl, it gives B of molecular formula C9H14O. When it is saturated with HCl, gives compound B, that is C9H14O. So what is the difference here? Here you have 3 carbon atoms, here you have 9 carbon atoms. Means you need to take 3 moles of this, okay? And 3 6 it is 18, but here you have 14. Means what is happening? The 4 hydrogens are coming out. The 4 hydrogens are coming out. That 4 can be written as 2H2. Okay. And here you have 3 oxygen atom. Here you have 1. So take H2. And here what is going to happen? The condensation is taking place. Now we shall take 3 moles of this acetone. 3 moles of acetone. For our convenience, I am going to write this as like this, and take 1 more acetone. Take 1 more acetone. Okay. When 3 moles of acetone is saturated with HCl, okay, what happens? Here condensation is going to take place. Now H2 from this will combine with O. 1 H2O will be released, and here also. Here from 3 hydrogens, only 2 is coming out. 1 H will be there. Here also 1 H will be there. So now on condensation, what we are going to get? CH3, CH3, double bond, C double bond O, C double bond, CH3, CH3. This is called as 4-one. This is called as 4-one, and whose IUPAC name is here. Count the carbon atoms 1, 2, 3, 4. At the position 4 we have a major functional group, that is a ketone, and from here also 1, 2, 3, 4. Okay, no problem. You may move from this end or from this end. Okay, let us move from this end. 1, 2, 3, 4, 5, 6, 7. There are 7 carbon atoms, and here prefixes are methyl groups. These are presented as second and 6 carbon atoms. So I can write this as 2,6 dimethyl. 2,6 dimethyl hepta, and here we have 2 double bonds. one is present at the second position and the other one is at the fifth position. So therefore 2 comma 5 diene. Okay, and here we have a 4 one, that is the ketonic group is present in a 4 carbon atom. So 4 one. 4-on is a product formed due to condensation of the acetone molecules with HCl. Okay, and here the IUPAC name is 2,6 dimethyl hepta 2,5 diene 4-one is the IUPAC name. This is the compound B. Okay, now look at the question 5. What is A and B? A is what? Acetone or it is a propanone. Okay, it can be called as acetone or propanone. And B is what? B is 2,6 dimethyl hepta 2,5 diene. Okay, diene 4-one. Okay, so therefore the option 3 is the correct answer. Option 3 is the correct answer. Option 3 is the correct answer. Okay. And go for the next question number 6. In nucleophilic addition reactions, the reactivity of carbonic compounds follow the order. Let us see what are the carbonic compounds are given in this. Okay, carbonic compounds given are, one is CH2O. This is what? Formaldehyde. Okay, next is R2CO. This is what? Ketone. Okay. Next Ar2CO. This is aromatic ketone. Next is RCHO. Aliphatic aldehyde it is. Then ArCHO, that is aromatic aldehyde. So here during nucleophilic addition reactions we know that the aldehydes will readily undergo. Okay, and in the aldehydes, which one will readily undergo? The aliphatic aldehydes. While in aromatic aldehydes, the polarity will be reduced due to the resonance. Okay, and here in the aliphatic aldehydes, the simple aldehyde will be undergoing the nucleophilic addition reactions readily. Okay, here it is the simple aliphatic aldehyde. Aliphatic aldehyde. This is what? A aliphatic ketone. Aliphatic ketone. This is the aromatic ketone. Aromatic ketone. This is aliphatic aldehyde. Aliphatic aldehyde. This is what? Aromatic aldehyde. What I told? For nucleophilic addition reactions, the simple aldehydes will readily undergo, followed by aliphatic aldehyde. The simple aliphatic aldehyde is this. This will readily undergo because of least steric hindrance and less electronic effect. Okay. Followed by the aliphatic aldehyde. This is the aliphatic aldehyde. Okay. Then followed by the other aldehyde, that is aromatic aldehyde. Then followed by ketone. In the ketones, the aliphatic ketones will readily undergo R2C double bond, and lastly the aromatic ketones will undergo the reaction. Why this order is followed? See, in the nucleophilic addition reactions, the nucleophile is coming now with a negative charge. Okay, if there is a steric hindrance in the molecule with electronic effects, then it cannot readily undergo. Okay, the carbonyl compound with least steric hindrance and least electronic effects will readily undergo the nucleophilic addition reactions. Therefore, this order will be followed. Now, look into the options. Which one is correct? Option 1 is not following this order. So, option 1 is wrong. Option 2, look at this. CH2O, RCHO, ARCHO, R2CO, Ar2CO, it is correct. So therefore the option 2 is correct answer. Option 2 is correct answer. Okay. Now come to the question number 7. Which of the following statements about benzaldehyde is not true? About benzaldehyde is not true. Question number 7. They are asking about benzaldehyde. Okay. It is an aldehyde. Keep in mind that it is an aromatic aldehyde. Okay. Benzaldehyde undergo tolerance test. Yes, it is correct. Okay. Benzaldehyde undergo tolerance test. Okay. But they are asking about which is not true. Which is not true. Okay. And what is the option 2? Undergoes aldol condensation. Okay. Say benzaldehyde is not having alpha hydrogen. Alpha carbon is this. Alpha carbon. Here it is not having hydrogen atom. But here the hydrogen is there. Here also. Hydrogen is not present on the alpha carbon. The carbonyl compounds with alpha hydrogen will undergo the aldol condensation. Okay, but here benzaldehyde is having no alpha hydrogen, therefore cannot undergo aldol condensation. Okay. So therefore option 2 is the not correct statement. That is the answer. Option 2 is the answer. Okay. Now come to the question number 8. Oxidation of butan-2 can be achieved by. They are asking about oxidation of butan-2. See, it is a ketone. The oxidation of aldehydes is easy. It can be achieved with even mild oxidizing agents like Tollens reagent, okay, Felling's solution, okay. But the ketones require a strong oxidizing agent for oxidation. These require a strong oxidizing agent. Now, find out the strong oxidizing agent in the below options. Option 1 is Tollens reagent. It is a mild oxidant. It cannot oxidize the ketones. Second one is concentrated nitric acid. It is a strong oxidant. It can oxidize the ketone. So therefore, option 2 is the correct answer. Why not the option 3? Okay. Option 3 is bromine water. It is a mild oxidizing agent. It attacks on the unsaturation. Okay. Next, atmospheric oxidation is not possible for the ketone. Okay. Yes. Go for the question number 9. Which of the following reagents is used to distinguish the acetone and acetophenone? Okay. Distinguishing. They are asking about distinguishing reagent acetophenone and acetone. See here, it is a aliphatic ketone. Okay, it is aromatic ketone. When you look at the structures, this is CH3, C double bond O, CH3. This is CH3, C double bond O, and a benzene ring. This is an aromatic ketone. Okay, here the aldehydes and ketones react with the NaHSO3. sodium bisulfite or sodium hydrogen sulfite. Okay. In the ketones, only the aliphatic ketones undergo this test, but not the aromatic ketones. So that is why the suitable reagent to distinguish these two is sodium hydrogen sulfide. Okay. So therefore, the option 1 is correct answer. Option 1 is correct answer. Why not the option 2? It is a Grignard reagent. Option 2 is a Grignard reagent. It reacts with both these compounds. Okay. We need a reagent with which we can easily distinguish these two. But Grignard reagent reacts with both these. Okay. That is not a suitable reagent. And Na2SO4, the ammonium chloride, are not the suitable reagents. Okay. So go for the question number 10. Cyanohydrin of which of the following forms lactic acid? They are asking about the formation of lactic acid. Let us know what is lactic acid. Lactic acid, it is 2-hydroxypropanoic acid. So what is lactic acid? It is 2-hydroxypropanoic acid. 2-hydroxypropanoic acid. Okay. Let us see its structure. For example, we have propa, okay, like this, 2-hydroxy, okay, propanoic acid. This is the lactic acid. Okay. Now cyanohydrin, which of the following compound? Let us see that the question number 10. Cyanohydrin of which of the following? Here we have to choose the compounds. Cyanohydrin means there one insertion of the CN is there. Cyanohydrin, there insertion of CN is there. The given compounds are carbonyl compounds. Means when you insert this carbon, how many carbons we need to have? The 3 carbon atoms. Okay. So here we have 1 carbon. See, you need to select a carbonyl compound containing 2 carbon atoms. Which is one? That is, the first option is having 1 carbon, that is not sufficient. The second is having 2 plus this second one is having 3. This one 4 it will be, but the propanoic acid is having only 3. And go for the option 3, where we have CH3, CHO. Okay, but this undergo the reaction with the HCN. The addition of HCN to the aldehyde will form cyanohydrin. Okay, like this, CH3, COH, CHCN, and it on hydrolysis gives CH3, CHOH, COOH. I already told you that the nitrile or cyanide, we can simply write the CN or C triple bond N, no problem. When it is hydrolyzed, it will give the carboxylic acid, and the remaining will be the ammonia, gas. So this is what? Lactic acid. Okay, cyanohydrin of the acetaldehyde will give the lactic acid. Therefore, option 3 is correct answer. Now come to the question number 11. Acetaldehyde cannot exhibit. So we know about the acetaldehyde. Okay, it undergoes silver mirror test, that is nothing but Tollens test, Welling test, Benedict's test. Okay, and it also undergo aldol condensation. Let us see what are the options. Acetaldehyde cannot exhibit the 1 iodoform test. It is a methyl ketone, therefore undergo iodoform test. Okay, Lucas test. See, Lucas test is a test for identification of the alcohol but not the aldehydes. So therefore, it cannot undergo or cannot give Lucas test. because this Lucas test is a test for identifying the alcohols. Okay, so therefore option 2 is the correct answer. Option 2 is the correct answer. Okay, go for the question number 12. The benzaldehyde on treating with HCN gives. Okay, let us see that. Question number 12. Take the benzaldehyde C6H5 C double bond to H. Okay, when treated with HCN, okay, gives the compound C6H5 CH CnOH. They have given this. Okay, the product would be option racemate, optically active, mesocompound, mixture of diastereomers. Means they are asking about the optical activity of the compound. Okay, carefully understand that this is a trigonal planar compound. Trigonal planar, because this carbon is sp2 hybridized. Okay, it will be like this. Here, the cyanide is going to attack on this carbon. No, it may attack from this end or from this end. Okay, there is both the chances. Okay, it may be a dextrorotatory or maybe a levorotatory. That will be 50%. So the cyanohydrin of this benzaldehyde will have 50% of the dextrorotatory compound and 50% levorotatory compound, that will make the mixture of D and L isomers that will be optically inactive racemic mixture. Okay, so therefore option 1 is correct answer. Option 1 is correct answer. The cyanohydrin of this compound will be optically inactive racemic mixture or racemate. Now, question number 13 is, if acetyl chloride, what is acetyl chloride? CH3, C double bond O, Cl, is reduced in the presence of barium sulfate, sulfur, palladium. Okay, so this is what a Rosenmund reduction. Rosenmund reduction. Okay, the reduction of acid chlorides to corresponding aldehydes. So therefore we will get CH3 C double bond H, that is acetaldehyde. So Rosenmund reduction of this acetyl chloride will give the acetaldehyde. So now see the options. CH3CHO is formed. So that is the option 1 is correct. Option 1 is the correct answer. Option 1 is the correct answer. Okay. Now go for the question number 14. C2H5CHO. This is what the propanaldehyde. Propionaldehyde and acetone can be distinguished by testing with. Okay. See, one is a ketone, the other one is an aldehyde. This is what? CH3, CH2, C double bond OH or CHO, and the acetone CH3, CO, CH3. This is the ketone. This is the aldehyde. Okay. We know the differences. Aldehydes readily undergo tolerance test. Aliphatic aldehyde undergo Fleming's test, Benedict's test, and this cannot undergo the tolerance test and the Fleming's test. Okay, but these two will undergo the nucleophilic addition reactions. Okay, let us see that. Phenyl hydrogen, it is a reagent. It reacts with both the compounds. Okay, this cannot be used to distinguish these two. Hydroxylamine, it also undergo nucleophilic addition with these two, so cannot be used for distinguishing the compound. Fleming's solution, it reacts with the Fleming's solution, but it does not react with the Fleming's solution. Okay, by the Fleming's solution we can easily distinguish these two. When the aldehyde is treated with the Fleming's solution, you will get a reddish brown precipitate, and this won't give you that precipitate. Okay, you can easily judge which is an aldehyde, which is a ketone with the ferric solution. Therefore, the option 3 is the correct answer. Option 3 is correct answer. Go for question number 15. Which of the following compounds containing carbonyl group will give colored crystalline compound with the 2,4 DNP? 2,4 DNPH. What is that? For example, it is NH2, 2. This is the position 2, 4. Okay. 2,4 dinitrophenyl hydrazine. Okay. 2,4 DNPH it is called. Okay. This, when added to the carbonyl compound, undergo the nucleophilic addition reactions. Okay. Now, the carbonyl compounds undergo the nucleophilic addition reaction with this 2,4 DNPH. Okay, let us see options. Which of the following compounds containing carbonyl group will give the crystalline compound? See, when this is treated with the carbonyl compounds, then it will show a hydrozone that will be yellow, orange or red crystalline solid. Okay, yes. The first one is CH3COCl. This is neither an aldehyde or a ketone, so therefore it does not give. Okay, so come to the option 2. This is a ketone, CH3COCH3 ketone. Therefore it undergoes reaction with this hydrogen to give hydrozone. Okay, and that hydrogen will be having a crystalline precipitate. Okay, so therefore option 2 is right answer. Okay, come to the option 3. This is an ester, CH3 C++O C2H5. This is also neither an aldehyde nor a ketone, so it cannot undergo. And the fourth one is amide, acetamide, CH3 C++O NH2. So these compounds cannot undergo reaction with this 2,4 DNPH. Only the ketone will undergo. Therefore, this is the correct answer, and the product will be having a colored precipitation. Okay, yes. Go for question number 16. A substance C4H10O yields on oxidation a compound C4H8O. On oxidation yields C4H8O. Okay, what is coming out? 2 hydrogens are coming out. Okay, 2 hydrogens are coming out. Okay, this is called oxidation. Removal of hydrogens is called oxidation, which gives an oxime. Means it is going to react with the hydroxylamine. Okay, then only it can give an oxime. So which one will react with the hydroxylamine? Either aldehyde or ketone will react with the hydroxylamine to give the oxime. Okay. And a positive iodoform test. It is undergoing a positive iodoform test. Okay. Then it must be a methyl ketone. This part will be there. Okay. Then the original substance on treatment with the concentrated H2SO4 gives C4H8. This, when treated with H2SO4, gives C4H8. So what is happening here? H2O is coming out, isn't it? Okay. Yes. Means it must be an alcohol. Okay. And what it will be this CH3, CO, CH2, CH3. Okay. Here C4, okay, H8, okay, 1 oxygen. Okay. Yes. Now what is their question? The structure of the compound is, the original compound is. See, it is a ketone, no? Now we came to know that it is a ketone. Which one will give this secondary alcohol? Secondary alcohol will give the ketone on oxidation. So therefore it must be a butane 2OL. It is a secondary alcohol because this functional group containing carbon is linked to two other carbons. No? So therefore this is a secondary butane 2OL. It is a secondary alcohol. So go for the options. Option 1 is butane 1OL. It is not the correct answer. Go for the option 2. It is an answer. Option 2 is correct answer and it is the butane 2OL, which on oxidation gives a butanol as a ketone. Okay, and this reacts with the hydroxylamine to give the oxide. Okay. Butane 2OL when treated with concentrated sulfuric acid gives a butene as the compound. Okay. Yes. Go for the 17th question. 17th question is which of the following will react with the NaOH to produce an acid and alcohol? Where we can get an acid and an alcohol? In the Cannizzaro reaction. In the Cannizzaro reaction, where a carbonyl compound with no alpha hydrogen undergo reaction with the concentrated NaOH or KOH to give an alcohol, okay, and a carboxylic acid salt. Okay. So here, which of the following compounds are having no alpha hydrogen? Okay, go for the option 1, HCHO. Formaldehyde having no alpha hydrogen, therefore it undergo reaction with the alkali to give an alcohol, that is methanol, and the salt of carboxylic acid is HCOK or HCONA. Okay, so this is the reaction. Okay, the question is very simple. Okay, they have indirectly asked about the Cannizzaro reaction. Okay, therefore option 1 is correct answer. Option 1 is correct answer. Why not the option 2? Option 2 is the formic acid. Okay, formic acid cannot undergo the Cannizzaro reaction, and the third one is propanoic acid. Next, the option 2, 3, 4 are carboxylic acids. Okay, these cannot undergo the Cannizzaro reaction. Okay, go for the question number 18. Which of the following gives aldol condensation reaction? So recall the aldol condensation. To undergo this reaction, the carbonyl compound must have alpha hydrogen. The carbonyl compound must have alpha hydrogen. Come to the option 1. It is a phenol. First of all, this is not a carbonyl compound, so it cannot undergo aldol condensation. Okay. The next one is a benzophenol. The option 2 is benzophenol. It is a ketone not having alpha hydrogen, so this cannot undergo aldol condensation. Come to the option 3, that is CH3, CH2, C double bond O, C6H5. See, with respect to this carbon, this is an alpha having hydrogen, so the carbonyl compounds with alpha hydrogen undergo aldol condensation. Therefore, option 3 is the correct answer. Okay. Yes. Come to the question number 19. It is which is not true about acetophenone. So acetophenone does not react with the sodium hydrogen sulfide. That you need to remember. Okay. It is a carbonyl compounds reacts with a 2,4 DNPH, as we have already discussed. It reacts with Tollens reagent. See, which one will undergo Tollens test? The aldehydes only. What is this? This is a ketone. So therefore it cannot undergo the reaction with the Tollens reagent. So this is the incorrect statement, and the right option, option 2 is the correct answer. It is a wrong statement regarding the acetophenone. Okay. Now come to the question number 20, that is acetone reacts with Grignard reagent to form. Okay. Acetone reacts with the Grignard reagent to form. See, we have acetone reacts with any Grignard reagent. You may take for example RMGX, where R is having a carbon atom. Okay, for example take CH3. Okay, it is a Grignard reagent. Here CH3 attacks on this carbon. Okay, so on treatment with this, it will be forming OMGX, then it will be CH3, CH3, and this one will attack on this, and again it is a CH3, and when it is hydrolyzed gives an alcohol OH, CH3, CH3, CH3. So what kind of an alcohol it is? The functional group containing carbon is this. It is linked to 3 other carbons, hence it is a tertiary alcohol. In the IUPAC system, you can call this as 2-methyl propan 2-OL or tertiary butanol. So the obtained alcohol is tertiary alcohol. Therefore, the option 1 is correct answer. Option 1 is correct answer. Okay. Remaining MCQs we shall discuss in the next class. So you try to solve each and every MCQ. Okay. These questions are very simple and are very important. These are purely based on the topics which we have discussed in the classes. Okay. So be confident on yourself while solving the problems. Simply write what they are asking for. Okay, try to remember all theoretical concepts and keep on remembering the functions of the reagents, named reactions, etc. Okay, thank you.